How do we grow this influence of black leaders, men and women, that can represent our industry inside the ANC, inside the policy-making structures?
Get to grips with the digital environment, put together best practices, what works and what doesn't, very importantly.
In the project that we're doing in Chatlash, we've created a linking bridge between those two little areas there. So it becomes a matter of just 10 minutes walk from one side to the other.
So my message to our CEOs and those chief investment officers is, where at the end of the day do you want to see your role?
So by treating all of our water back to a stage where we can bring it back into the process, we're in effect saving around about 35% of our water usage on site.
Welcome to greeneconomy.tv. My name is Gordon Brown. I'm the publisher of Green Economy Journal. And we have with us today again to speak about the circular economy, Chris Whyte from the African Circular Economy Alliance. And we have Nolwazi Mbhele, as always, from CPUT, from the Cape Peninsula University of Technology, where she's an environmental science student. So today, as part of the Circular Economy Show, we're talking about construction, buildings, and the circular economy. Without further ado, let me invite my guests to join us, and let me ask you, Chris, Nolwazi, how are you doing today?
Good, Gordon.
Hi, Gordon. Hi.
Good stuff. So we started out this particular show many weeks ago now. We spoke about circular economy, what it means globally. We spoke about the context in South Africa and in Africa. And since then, we've started down this road of looking at circularity within specific sectors. And as I mentioned today, we're looking at construction and buildings. So, Chris, just to get us going and give us the high level context of this conversation, what is wrong? What are the problems? What are the impacts that we're experiencing within construction and buildings that has needed to be addressed and has now triggered this thinking around circularity? And what are the key linear patterns that we're seeing that are triggering these impacts, and how can we change these into a better, more circular approach?
Yeah, thank you, Gordon. I mean, obviously, the built environment and construction sector is under the spotlight at the moment. It has been for a while. One of the main reasons, of course, is that everyone always known that it's a high energy industry, and that there's a lot of waste that comes out of that industry as well, from construction and demolition. And that fills up our landfills, and landfills are expensive and they're precious space. So we need to look at other alternatives. The big issue from our perspective really is understanding the embedded energy in a lot of the conventional materials that we look at. So we have cement as a single industry that contributes some 8% of total carbon emissions that contribute to global warming. When you put that into context with the built environment, it's about 39%, I think, is the average that is quoted most often. 39% of carbon emissions they come from the built environment that contribute to global warming and climate change. So when you put that into context, and we think about Africa, Southeast Asia, we need to house another 1 billion people over the next 30 years. If we continue to build with cement and steel and concrete and clay brick, all these high energy intensive systems, we're not going to meet our climate goals. We're not going to meet our carbon reduction emissions. And it really is just the simple fact that we've moved into a particular direction of a sort of non-sustainable path, where we're looking at a really energy-intensive process of utilizing carbon-based systems for cement production, where we need to mine the products out. It then goes through a high energy system to create a clinker that gets ground. And we end up with a very, very high CO2 emission factor from cement and concrete. So we need to look at how we change that. And there are alternatives. There are different materials. But we've also stuck with a bit of a legacy. So what do we do with all these buildings that we've already built that are thermally inefficient? How do we look at making sure that in future we build smart, that we use low carbon systems, and that we use both active and passive design to manage the built environment? So there's a lot of different components to it. And the circular economy provides a host of opportunities and applications and solutions for changing this dynamic.
Okay,
absolutely. And so thanks very much for that high level there. Nolwazi, I'm going to switch over to you, please. Can I ask you to fire away with your first question?
Okay, so we know that the construction industry contributes like to 25% of solid waste. What are the benefits of implementing circular economy in construction?
In construction or demolition? So if we're looking at the construction waste, the first opportunity would be to reutilize that material. And again, we need to look at either low value or high value applications. So the fact that we are filling up our landfill sites with inert material like construction demolition waste makes absolutely no sense whatsoever. At the low end, it can be literally crushed up and granulated down into an aggregate that goes back into the system. So that's the first one one could look at. But then you also need to make sure that from a quality control perspective, you are maintaining engineering standards. The other application is to get a little bit smarter about it. And there are a lot of useful resources in old cement and concrete. And there's a lot of rare earths and heavy metals that are stuck in cement and concrete. Very few people know that. But that could be a valuable mining source. So pulverize old concrete and extract out the heavy metals and the rare earths. And then the pulverized material can be reactivated back into another cement or concrete application. Again, it depends on the application. Some people would be hesitant to use a recycled concrete for particular applications. But then we need to look at seeing how we drive and develop that where we don't have the same high level engineering or technical requirements. So the housing sector would be an easy one. You don't need the same strength in a single story building as you do in a 22-story apartment. But then also we need to look at applications in terms of making sure that we don't move products around. So yeah, we're shipping construction demolition waste vast distances into our landfill sites, and yet there are opportunities to look at small-scale applications where we can reprocess that material into an aggregate or into a local material that can be used more on site. So again, looking at the circularity of ensuring that you reduce the carbon footprint from that perspective. So there's many different ways of looking at it. The opportunity is also to look at the alternative materials, and I think that's where there's a bigger opportunity in the future.
Yeah. So Chris, I'm going to ask you a few questions about the new innovative and high tech products that are coming through, perhaps, and we can talk about some additives and some bulking agents and so forth. But just staying with this issue of construction rubble, and you've mentioned several times that it's clogging up the landfill sites. Perhaps I can ask you just to give us a bit more detail about that, because it's actually quite alarming, isn't it? I mean, you're dealing with a material that it doesn't decompose; it just sits there. It's taking up space, and of course there are also the leaching issues. There's their health considerations, but also perhaps talk about the stuff that doesn't even get to the landfill site, where the bucket builders might dump illegally. What are the implications of that? What are the costs of that to council? And how can the industry as a whole try to self-regulate itself so that it doesn't make sense for a bucky builder to dump rubble in the field, rather dump it somewhere where someone's actually going to valorize it.
It's a big issue, and Nolwazi nailed it on the head. We're talking about an average 30% of our materials that are going into our landfill sites are these inert materials, generally from soil waste, cut and fill operations, and from demolition applications. Not too much of an issue in terms of any leaching and pollution issues from there. It's just the fact that it's taking up highly valuable landfill airspace. And the problem is that we're seeing an increase in terms of fly tipping or illegal dumping, where as landfill sites start to realize that they have less and less space. I mean, you look at Cape Town and Johannesburg at the moment, they're in dire straits with regards to the availability of landfill airspace. What's going to happen is that the gate fees are going to increase dramatically to try and look at avoiding sort of landfill, and we're getting landfill directives to avoid specific materials. Cape Town, again, is a leader in this with regards to diversion of demolition waste, diversion of green waste. But as you start increasing that gate fee, what's going to happen is that more people are going to dump. And if you look at like the city of Johannesburg, and you look at just their budget alone for fly tipping, it's about 10 to 15 times more expensive to pick it up off the streets than it is to get it into the landfill site. So again, we need to look at two things. You need to look at the stick and the carrot. So you've got to get the stick out and nail people for doing it, because people are getting away with murder, and it's very easy to track people if you have the right sort of penalty system in place. But again, that's an enforcement issue which needs to be tackled. The better option is an incentive option, where we can look at providing free areas for people to dump this material, where the municipalities can then put on the equipment and the infrastructure to process that material, or it could be outsourced to the private sector. As long as you've got a push and a pull. So we can't just have somebody crushing it, but there's no market offtake for it. But if we changed the standards, and we said that for all new road construction, we had to have at least 30% crushed builder's rubble as our roads subgrade, you'd obliterate the entire country's problem in terms of rubble in one fell swoop, one policy, done. And in providing an offtake, you would provide the incentive for the private sector to invest in the crushers to be able to do it. So these are not difficult things to get around. It's just that we've got to look at the whole system and understand what those opportunities are. We need to avoid the illegal tipping, and that's going to be an issue of looking at the incentives and the penalties.
So let's chat briefly about the potential for reusing of building materials, right? So, and possibly also recycling. We're actually really talking about recycling there. We're taking rubble, etc., and grinding it down as a recycling solution. What about reusing? I mean, many buildings have great elements. I know that there are people that take out old window frames and all sorts of things from demolished buildings. And in fact, the demolition companies themselves are starting to see the opportunities there. To what extent with conventional buildings do you have to break the thing down? And to what extent is the market starting to come up with solutions where buildings are perhaps starting to be designed for deconstruction, so that at end of life, or perhaps even halfway through life, if there's a new tenant with a new objective, that you can somehow adapt the building, reuse, reconfigure. Perhaps chat about that, please, Chris.
You are starting to see that in terms of the redesign. There's a lot of different building technologies using SIP, structural insulated panels, and other components that can be dismantled and reconstructed into new applications, or sent to destruction applications. But we've got to look at all of the different opportunities in terms of again, if we look at a policy perspective, that would help us to drive the markets to look at diverting different materials. the application again needs to follow engineering requirements. So again, we need to look at where we are as a country with regards to our certification and our standards. We don't have enough standards in terms of looking at sort of SABS type standards or Argamar standards for different materials that are not over-regulated and over-bureaucratic, that block their application or usage into the systems. But we need to drive the whole system looking at it from a life cycle analysis perspective, from the beginning to the end. And we've seen some good stuff. The simple reality is it's a question of economics. So when one's demolishing a 50-story building, often it's just easier for the new developers to plug some ammonium nitrate in there and blast the thing to the ground. And then the real value of that product is not there. So things like door frames, window frames, bricks, blocks that can be recycled into a lower LSM system where people can't afford brand new materials. There's a huge opportunity there. And there are some good things that are being done. There's a couple of good examples in South Africa where they are looking at separating out these different materials and then looking at them for resale. And it makes sense when the scrap metal value of a window frame might be $30, but you could sell that same window frame into the secondhand market for $300. Now all of a sudden you're starting to see a different opportunity. But this is where we have a problem. We don't have extended producer responsibility in that sector. The concrete and cement industry, the construction industry, and the demolition industry, there is no extended producer responsibility involved. And I think that's something we need to look at as a country. But then we also need to be realistic in terms of understanding the value in terms of what can be done and the reality of what can be done. If you need to demolish piece by piece, brick by brick, a 20-story building, that takes a long time. Is it going to be worth your while in terms of looking at the economic value that you get out of it?
Okay, and then when we talk about design for the environment, does the longevity of a building matters? Does it have an impact on the environment or not?
Oh, it does, very definitely. So if you look at doing a carbon footprint analysis on any new structure or building, it's based on a design life. And the reason why they look at it on a design life, again, is based on this old linear model of thinking. So we look at a house that's made from brick and mortar, and it actually only has a lifespan of 60 to 100 years. We know there's buildings out there that have lasted a lot longer than that. But the thinking is that the maintenance and retrofit of those old buildings doesn't make sense from an economic perspective. It's easier to demolish and rebuild. And we've got to change that thinking. We need to start looking at retrofit. If you look at some of the directives in Europe at the moment, I mean, the UK, any European country at the moment, in terms of meeting their directives, there's a very clear understanding in terms of the contribution of the built environment to carbon footprint. And to meet their carbon reduction demands, they need to look at retrofitting, because you can't just look at saying, well, let's just forget about everything we've built over the last 2,000 years and just focus on the new stuff. You need to look at opportunities and applications in terms of either internal or external thermal efficiency adaptation on those buildings. And there's great opportunities there. There's some good materials that are out there. And we can use recycled materials for a lot of that as well. So we've got to unpack all of those different bits and pieces, but build something that's either going to last a lot longer or something that can be retrofitted easily or dismantled. So again, things like these SIP systems, I came across another one the other day where they're using municipal solid waste and compressing that into panels that they're using for building. It's being done, anything can be done. It's just a case of finding out what the market will accept and where the certification and compliance issues may block that.
Yeah, so Chris, I mean, let's chat about some specific examples of great products that you've either invented yourself or come across in your various travels and dealings that in your mind epitomize the type of move to a circular economy in respect of construction materials that really demonstrates the principle.
Absolutely. Again, I haven't really ever invented anything. I'm very good at stealing other people's ideas and making it better. But also, in terms of a circular economy, the approach is one of collaboration and communication. So there are a lot of good products out there. Find out which ones are going to work, help support them, and get them into the products and processes. The one that we developed locally through Use It, an NPO based in Durban, was the Rambric process, which is simply a compressed earth block technology. We won several global awards for that particular project for its low carbon application. Again, the opportunity there was just to take any clay bearing soil with more than sort of 7% on average clay, and mix that with 25% crushed builder's rubble and compress that in a dry process into a highly thermally efficient, structurally sound engineering product or masonry product that can then be used for construction. And we built over 20 houses with that. We built a beautiful big Catholic church in Chongweni. We built a massive recycling center in Hammersdale. And we've shown the application of it as one of the most beautiful low carbon sustainable building mediums. And even with that, the opportunity, if you look at your conventional construction, if you look at a hollow concrete block home, your average CO2 emissions per square meter are around about 760 kilograms of carbon dioxide equivalents per square meter build. The compressed earth block homes, or the Rambric as we called it, was 260. And of that 260 kilograms, 170 of those kilograms came from the concrete foundation, because according to the local building specification codes, we had to have a concrete foundation, which again doesn't make sense. So we need to look at also those applications, and there are opportunities for concrete. So concrete has an average 350 kilograms of CO2 equivalents per ton. Cement is obviously higher. Concrete is just a mixed aggregate. And yet the opportunity in terms of reducing that with non-carbonate-based systems or alkali-based systems, particularly aluminosilicates, that can be used as waste streams to produce new products like geopolymers. So now we can look at using fly ash and blast grit or mine tailings, anything with a sort of high aluminosilicate application, to use a low temperature, low carbon activation system that meets and exceeds the building requirements of concrete. So you have a product that's using 100% waste that is 30 to 40% cheaper than cement and concrete, and is 80 to 90% lower CO2 emissions. There's definitely opportunities from that perspective. And that's where we need to, again, look at it from a material specification point of view. But we need to look at collaboration. I mean, the opportunity is that we don't have enough waste being produced that allows us to be able to look at our entire infrastructure build. And we already have a well-established cement industry that is trying its best to look at its own carbon footprint and create a greener future for itself. So let's look at a hybrid of the two. What about the best of both worlds? If we can't do one or the other, let's look at a hybrid. So there's many different applications and opportunities. Also, if you look at some of these materials can be used in the retrofit of old buildings to look at increasing the thermal efficiency. And that could open up thousands of jobs across the country in terms of developing that, but we don't have the policies in place. So we need to look at policies, we need to look at the application, we need to understand the materials. And there are a number of them. So there's, if you look at Agramar certification, which is it's a process certification as opposed to a product certification, which is the SABS. So if you don't have an SABS standard, you now need to get an Agramar certification, which is complicated, expensive, and bureaucratically inefficient. But we need to be able to look at understanding, if anybody can go online and have a look at their systems, there are hundreds of alternative systems, but they're not being employed. So the reason why they're not being employed is because, again, we need to look at issues around material specifications, supply chain management, preferential green procurement. We need to look at application in terms of the banks being able to understand what these new materials are, so that when they are financing a a 5-story building made out of an alternative material, that they then know what that material is and that they are willing to put their money behind it. So there's a lot of issues involved in the system, but the options, the opportunities and the materials, the systems and the technologies are all there.
Okay, so we've been talking about solutions on this. And then my question is, how can these solutions speed up the rollout of low-cost housing in South Africa?
Oh, there's a great opportunity there. You know, we've got systems built, developed, and designed in South Africa. And again, comes back to Gordon's previous comment. You know, I'm often not the one who's inventing or engineering all these different things. I'm just a lowly geologist. So yeah, I'm still trying to figure out what I want to be when I grow up. But the opportunity is that we know what these systems are. And there's a great system available and developed in the Cape that has got more traction outside of the country than here. And that's a system that uses a metal framework using a foamed concrete that is a fraction of the price of conventional building technology and meets and exceeds all of the engineering requirements of RDP housing by a long way. And it's quicker and it's faster. So, you know, there are solutions there, but we've got to get them into the mainstream application. Even if you look at compressed earth block technology, what very few people realize is that the most successful compressed earth block technology manufacturer is Hydroform. It's a South African company. And they have exported over 5,000 of these housing development units into Africa. And yet we don't have very many. I think we've got like half a dozen in South Africa. And we don't have the systems to be able to implement that technology locally. Why are we not using our local technology and our local materials? They are there. We don't have to reinvent the wheel. We don't have to bring in foreign technology. We've got the systems, the design, the technology, the materials, everything to do it here cheaper and better. And often that comes down to material specification, because if you look at an RDP housing type thing, they'll come out there with a structure and they'll say, we want a hollow concrete block house with a steel frame roof and concrete roof tiles of this size and that dimension. So they tell you what they want, and they're inflexible in terms of accommodating the alternatives, whereas the alternatives would be cheaper, stronger, better, quicker, faster. And that's why we're not getting in there. So it's not the application that's a problem, it's the system that's a problem.
So just you're touching on a number of interesting points there, Chris. And one of the things I'd like you to just chat about is the fact that with green building, what we often find is that it's partially about a new technology, regardless of where that comes from, inevitably overseas. So a new tech, but very often it's also about bringing back an old approach, right? And I mean, we see this certainly from a thermal point of view, passive design, seeking to bring back the type of design engineering in buildings that predated the existence of lighting and mechanical cooling and so forth. And that's equally true with materials. You mentioned, you know, rammed earth. I mean, people have been making houses out of rammed earth for millennia. We've got a policy in the country to eradicate mud buildings, and yet a leading architect recently built his holiday house in the bush out of mud, and it's an architectural masterpiece.
Correct.
To what extent, you know, can we access these often labor-intensive industries and bring them into the mainstream? And I just want to mention, you mentioned Agrimar, you mentioned SABS, and there's been a long-standing frustration with these organizations. I do happen to know that there's a partnership in place now between Agrimar and the Green Building Council. There's a new eco building rating tool that's being developed by Agrimar. There's a website that's coming out. So I know that there are good people in these organizations doing good things. But I mean, from your point of view, and without laboring the point, I mean, how do you see what's the silver bullet? You know, if you were writing an open letter to the minister, you know, what would your advice be on this?
Well, if we go back to indigenous systems, I mean, let's be real here. Earth is the best building medium in the world. Soil is the most thermally efficient. It has the highest mass balance of any building medium that you can come across. If you look at the old Zulu infrastructure, in terms of the beehive domes, was probably the most efficient building system ever invented. The problem is that it now doesn't meet our strict requirements, and it doesn't meet our expectations. But there are technologies that will allow us to redevelop that. So there are rammed earth block technologies. There's the compressed earth block technologies that meet and exceed engineering requirements, and have the same benefits as earth building without the fallback or the problems of adobe. Adobe, you don't have a consistency of strength in materials, and you don't have a consistency in terms of the compression strength. And the simple reality is that you don't need something of a high compression strength for a single-story building. Let's go back to the basics and look at cost. And it's coming back. That the Thabo Mbeki presidential library that's going to be built soon is going to be built with rammed earth, because the architect has said, this is where we come from. If you look at the evolution of the grain silos, in terms of the evolution of our culture in Africa, we transitioned to a more urban culture through the way that we managed to store our grain, which we did with adobe grain silos, because they're efficient, they're strong, they're breathable. They last a long time. So there are all these different advantages, and we've lost that because we've got sucked into unsustainable high energy building systems that actually are not sustainable. So we need to change the way that we're doing things. We need to look at the hiccups and the issues we have with regards to our certification, our compliance, and we need to drive it from a perspective of saying, let's make it happen. Instead of putting up another 20,000 house RDP structure, let's say, right, put it out there. Let's look at what's green, and make sure that the specifications are that it has to be at least half the carbon footprint of conventional building. It must have a cost saving. It must look at local skills and applications, and just change the way that we're doing things. But we've lost the plot. So we need to open up our eyes, and sometimes, looking forward, it's good to look backwards.
100%, and also, create buildings that are more livable, communities that are better for all walks of life, education, amenities, access to transport, all of those good things. So, Chris, Nolwazi, that's all we have time for today. Thank you very, very much indeed for your contributions. Ladies and gentlemen, I'd like to refer you to some additional resources around this topic. Certainly, greeneconomy.media, plenty of information there about green building and related topics, and then positive-impact.africa. This is the website of the official publication of the Green Building Council, Positive Impact Magazine. Go and check it out, have a look. It's got everything you need there, and enjoy those resources. So without further ado, and from my side, I bid you farewell. We'll announce in the press in the very near future what our topic will be for next week. So we'll see you. Thank you very much indeed. Goodbye.
How do we grow this influence of black leaders, men and women, that can represent our industry inside the ANC, inside the policy-making structures?
Get to grips with the digital environment, put together best practices, what works and what doesn't, very importantly.
In the project that we're doing in Chatlash, we've created a linking bridge between those two little areas there. So it becomes a matter of just 10 minutes walk from one side to the other.
So my message to our CEOs and those chief investment officers is, where at the end of the day do you want to see your role?
So by treating all of our water back to a stage where we can bring it back into the process, we're in effect saving around about 35% of our water usage on site.